Okay, excellent. Let me just minimize the windows here as well. Okay, well, hello and welcome. Thank you for coming to our protocol training for the community-based restoration monitoring project that we are doing. My name is Jill Ariola, and I am the staff scientist here at ALLARM. ALLARM is the Alliance for Aquatic Resource Monitoring, if you're not familiar. And I'm joined here today with one of our watershed coordinators, Michelle Cow, who's going to be helping with the presentation. And then virtually, we have our volunteer monitoring specialist, Isabel Ruff, who also works with ALLARM. So we'll be taking turns and going through the information together because it's a lot. I don't want to scare anyone. I think it seems a lot when it's presented this way, but honestly, when we're in person doing it in the field, it goes by so quickly and we follow the manual and everything works out great. So if you do have any questions, I do ask that you wait until we have a break or until the end. Since this is being recorded, we'll just try to get through the information as best we can, and then we'll have plenty of time to address any questions that you have. So just to get started, okay. So our project partners on this monitoring program, there's a lot of them. NIFWIF, the National Fish and Wildlife Foundation, is kind of the overseeing organization. They provided us the funding to do this monitoring protocol. And we work closely with the Chesapeake Monitoring Cooperative, the Alliance for the Chesapeake Bay, and also the Stroud Water Research Center. Some of you have probably already talked to Maya, who is with the Alliance for Chesapeake Bay, and she's kind of our co-patriot in this project. So what are some expectations and what level of engagement can you expect as one of our volunteer monitors? Well, first, before you came to this, hopefully you attended the initial orientation session. It's probably 30 minutes, just a really brief overview of the protocol and where this project got started and the purpose of the project. And now you're attending the protocol training. So now you've done the second step, which is part of our expectations. So this is going to be hopefully about an hour and a half just to cover everything and to go over questions. After this, you will fill out a volunteer waiver and then also sign up for a site. And at the end, we will have a list of some sites that are available for monitoring and who to contact if you're interested in a particular site. So what are the goals of this restoration monitoring? We want to know if the processes that we're putting in place for restoration are working. And if the changes are occurring due to this restoration, what we call intervention. So we're going to be collecting data using this protocol. And the data will show us what changes are happening pre-restoration and post-restoration. Did this work? Is it actually doing what it's intended to do? Are the in-channel alterations having the intended effect? And are the planted buffers, if there are any, are they surviving? You know, are the, like you can see the green tubes there in the photo. You know, are those trees still alive or not? We do want you to dress for the occasion. It's recommended that you have the following when you come out with us into the field. Please bring a full water bottle, especially when we get into warmer months. It's going to be really important that you have water. Wear long pants. We will be walking through some grass fields, maybe some woods to get to our site. So possibility of ticks is there. Please sunscreen. I didn't wear sunscreen today. I definitely got a little bit of a sunburn being out in the field today, so highly recommended. Closed-toed shoes or boots. Rain gear as needed. We do try to book the monitoring events on days that are good weather, but sometimes pop-ups happen, so just be prepared for that. Any extra clothes, I can tell you from wearing waders, sometimes you forget how deep the water is and you bend over and then whoosh, all this water down the front of your wader. So it's always a good idea to just bring an extra set of clothes with you. Speaking of waders, you don't have to have any. It'd be great if you do and you bring them with you. We do have waders that we can provide to our volunteers, but you do need to give us a heads up before we go out there. And it is first come, first serve. So even if you have muck boots or anything like that, bring those with you. Make sure you are prepared. So this site's, you know, it's pretty variable depending on where we go. We do have sites kind of all throughout the Chesapeake Bay watershed. We cannot promise access to bathrooms. So it is important to plan ahead. We will usually know where in the area is an accessible bathroom. It might not be a walk, it might be a car drive. So that's just something to be prepared for. There can be electric fences. However, we do ask the landowners that those are turned off. Um, but it's just best to be aware that there is fencing. The fencing could be electrified. So that's just something to be aware of. Don't just grab any fence. Um, there can be livestock in the area. So some of these BMPs are for cattle, and so there can be cattle nearby. They should be away and on the other side of a fence from us, but just be prepared that there can be livestock. Again, ticks, other insects, so bug spray, something like that will help. There can be poison ivy, stinging nettle, other plants that can cause irritation. I walked through a big brush of thorny bushes today, so that was something I had not mentally prepared for, but that's just, kind of be prepared for a range of environments. And then again, inclement weather. We do try to avoid rainy days, but sometimes it does happen. So just be prepared. All right, so for the site arrival and preparations, before I get into this, I am going to say the overall goal of bringing volunteers in is that hopefully one day after you've done this monitoring a few times, you don't need us to go with you. So hopefully groups of volunteers can go out by themselves to do this monitoring. So the next section is kind of geared towards that. So before arriving on the site, make sure you've reviewed the paperwork. Again, if you go out with me or with Maya, we will have done that ahead of time. And just, familiarize yourself with the project. Communicate with the landowner or whoever is the project point person. We will provide you that information. And it's really important to know where to park. Sometimes it's not very obvious, and sometimes where you park changes depending on where you go. So these are really important things to know, especially when groups of volunteers go out with one of us with you. For now, because this is new and you're going through the training, when you go do these projects, we will be with you. We will have that information for you. Once you're on the site, reach the first transect. We'll go through that and the photo markers. Make sure that your site is still set up and you know where you're taking your transects, know where you're taking your photos. Replace the markers. Sometimes they're just pink flags or flagging tape around a tree. Sometimes they just fall off or go missing, so we replace those. And then just make sure that you can assess the access points to get into the stream. Stream banks do change over time, and so maybe where you accessed it before might be different this time. We always want you to be safe. Please don't try to do anything that you wouldn't try normally, because your safety is honestly the #1 priority. And when you do go into the stream, be careful not to disturb the transects because we are going to be taking data and we don't want to be walking all over the transects before we get a chance to actually observe them and write down our observations. So what are we expecting in a typical data collection day? So once we've arrived, we take our physical water quality indicators, which we'll go through here in a little bit. We do the complete visual physical assessment. We take standardized photos. And in the spring only, we collect benthic macroinvertebrates. And we'll go through all of these here in just a little bit in the protocol, but this is kind of the general order that we do things. So the schedule, this table is a little busy, but just know that we do a pre-restoration visit. Typically we do that ourselves and then the volunteer monitors come post-restoration. So we do at least one visit before, and then after restoration, we visit twice a year. So we visit once in the spring and then we go back in the fall, and we do that for 2 years. And then for years 3, 4, and 5, we only go once a year and we go in the spring, and usually we take benthics, but not every single year. So it just depends on the year that we are attending. So just keep that in mind, twice a year for the first 2 years, once a year for the years after that. And I just want to shout out, that's Isabella on the right there in the photo. Okay, do we have any questions so far? I know that was a little bit of a blitz just to kind of get you familiar, but does anybody have any questions? Let me see how many people we have. Oh, Daphne made it. Great. Hi, Daphne. Okay, perfect. I'm going to keep going then. So our next section, get Isabel's beautiful face out of the way there, is going to be the first set of techniques. So these are going to be our in-stream measurements. And this section, Michelle is going to lead us through.
Right, sweet. Thanks for the transition. So in our in-stream techniques, we have two main techniques, temperature and water clarity. And our in-stream measurements are really useful for observing the changes via season as well as year. And we will need a HANA digital thermometer and transparency tube to complete this part. Okay. So the first parameter is temperature, and temperature is the amount of heat or how warm something is, and it's typically recorded in Celsius. And temperature is really important because it impacts the biological life and physical parts of the stream and ecosystem surviving it, mainly because direct sunlight heats up the stream and water really quick, which helps to stimulate growth and reproduction, but also decomposition of organic materials such as plants and water. And then there's also the aspect that warm water holds less oxygen compared to our cold water. Cold water, trout, um, water is what I'm thinking. And so with less oxygen, there's less oxygen to sustain life in the streams. And so as our restoration projects come in, a big bulk of it would be planting trees, and they're mini to begin with in the green tubes, but as they grow and mature, they'll hopefully provide shade and cover to our stream. So we would, in theory, expect lower stream temperatures. Okay. So first, to measure air temperature, we would take air temperature before water temperature, and we will use the HANA digital thermometer to do that. And this air temperature will be taken downstream of the transect just once, whereas for our water temperature, we'll take this measurement 2 times, both downstream and upstream, so we can hopefully gauge a center ground between the entire breadth of the stream. And so for the temperature, we'll be taking replicates for each replicates each time, and they will be between 0.5 Celsius of each other. If they're not, go ahead and take another replicate. The next parameter is water clarity, and water clarity essentially gets at how much light passes through the water or how clear the water is. And so water clarity is measured because sunlight is really important in water. Sunlight helps to support plant growth specifically, which brings in more oxygen, and the oxygen supports wildlife and life in general in the water. So more oxygen means more plants and more animals and a thriving stream. And so in order to measure water clarity, we use a transparency tube as Joe's showing. This transparency tube has a sprout on the bottom with a clip point where you can release water, as well as this funky looking disc on the bottom end of it, and it's called a Secchi disc, where there's 2 black triangles and 2 white triangles. And essentially, the contrast is what we're looking at to see how clear the water is. And then on the face of the transparency tube, there's a bunch of numbers, and that's how we do the recordings. So when you're out there in the stream, you collect this water clarity sample upstream, so the water's rushing and gushing towards you, and you scoop up that water, and then you slowly release it with the sprout until you're able to see just the faint contrast between the 4 triangles on the bottom. And then with the measurements on the side, once you see once you see a faint like sighting of the disc, then you can take the measurement on the side and record it. And similar to our other parameters, we'll also be taking replicates. So be sure your reps are between or within 10 centimeters of one another. And if they're not, you can go ahead and take another one. Okay, so now I'll pass it to the audience. So we have 4 pictures of the transparency tube with different levels of um, how turbid they are. And so in which case do you think we can stop draining the water and take the reading?
Yeah, so we can do like A is the first one, B is the second, C, and then D. So which one do you think you would stop dumping the water out? We have a chat entry.
So in the chat, there's a D as an answer. Does anyone else have any ideas as well? Feel free to put them in the chat or unmute yourself and you can say as well.
Another chat.
Another chat, another response for the 4th picture.
Ah. All right, well, which one is it, Michelle?
Yeah, so D is super close, but C would be where we stop the water. And I'm sorry if I didn't make it clear earlier, but when we stop the water spout, once we can see a really faint disc. So technically, if you look hard enough on the 3rd picture, we're able to see the contrast, and that's essentially when we stop the snout of the tube and take the reading.
Yeah. Very close, but
yeah, really close.
That's why we're doing this. Yeah. Okay, perfect. So next, thank you, Michelle, very much for doing that for us. So we're going to go into the cross-sectional measurements. And I think this is Isabel.
It is. All right, yeah, so there are going to be 3 established transects that are going across the stream. So there will be a stream reach, which is the entire sample area, and 3 transects going across. So we'll have one at the upstream point, one downstream, and one at the mid-reach, being able to capture kind of the entire stream reach. And so, like Jill said, they'll be marked with flagging tape. I think there also will be coordinates as well in case some of the flags disappeared. And these are already established before you'll visit your site this spring. So along each transect, you'll be doing measurements at 3 cross-sectional points. There's a lot of terms here. Transects, cross-sectional points. I'll be using them a bunch throughout this. And so to set up your cross-sectional points, you'll need a tape measure and gauge sticks. And then you'll use those gauge sticks and stream viewers to conduct the measurements. Yeah, I believe I'm good. Sorry, I'll say that again.
Yeah, you're good.
So you'll begin by measuring the wetted width. Now, this is the distance from basically across the stream from water's edge to water's edge. So it's basically the width of the water in the stream, which is where that term wetted width, I think, comes from. And you'll measure this with the tape measure and record that width on your data sheet. Now, keep that in mind because you'll be using those measurements in just a minute as well. All right. So using those wetted width measurements, you'll calculate the 25, 50, and 75% measurements to establish points that are going across the stream. So this is where some math comes in. So you'll measure, using that tape measure. Once you determine your points, go from, sorry, I'm getting ahead of myself. Start from left bank, which will be the bank that's on your left when you're looking downstream. So the way we're going to be orienting in this throughout this protocol is facing downstream. We'll also start downstream and work our way upstream so that we're not disturbing sediment as we go along. So going from left bank to right bank, that's how you'll establish your 25, 50, 75% measurements. And once you figure those out, put a gauge stick at each one of those points to mark its location. This is where it's nice to have some friends with gauge sticks and you all can stand and mark those spots. Um, and basically your goal should be like this picture on the slide here. And the exact location of your cross-section points may vary over time as the stream widens or narrows. And so I'm going to go through a bunch of measurements and parameters you'll be monitoring. And for each of these, you'll be monitoring them at each cross-section point. So everyone at a point will be doing all of those measurements. All right, we're going to start with water depth. So this is a measurement of how deep the water is. And this can help identify changes in the stream bed. So you're going to use that gauge stick, which conveniently you're already holding in place at your 25% point. So you're all set up for this parameter. And you'll hold the gauge stick with the numbers facing downstream, so that sometimes the water tends to pool up at the top of the gauge stick if it's running very fast. And so by facing the numbers downstream, you'll be able to get a little more accurate of a reading and read the value at the water level. So I believe these gauge sticks are marked at every 2 centimeters. And so that's where your recording will be. Yeah, and then also if the cross-section point falls on a sandbar or part of the stream that is not underwater, you can list that depth as 0. And again, we'll be doing this for all 3 cross-section points. So for these next measurements, you'll be using a stream viewer, which you can see Michelle grabbing right now. They're little traffic cone looking things, and they let us get a really clear look at what's going on beneath the surface. It can really help with bigger streams or times when there is some more turbidity. It, yeah, really helps with getting a clear view to what's going on the stream bed. So using the stream viewer, again, you'll do this at each one of those cross-section points. You'll be taking 4 different measurements. So substrate size and composition, periphyton percent coverage. Don't worry, I'm going to describe what periphyton is in a few slides. Periphyton thickness and embeddedness. And while you're using these stream viewers as well, make sure to take an image through one of them so that the CMC partners can help verify your results. So make sure to do that at every transect as well. All right, let's start by evaluating substrate material. So substrate can be broken down into categories based on size. So for this measurement, you'll be looking through the stream viewer and using that to define your field of view. So you can see an example of that there on the slide. And you're really focused on what you can see in that one spot in the stream viewer. And you're going to be determining what percentage of the substrate falls into each of these 5 categories. So boulders are really big. They're going to be greater than a basketball. Cobbles are from like golf ball to basketball size. Gravel is smaller, like sesame seed to golf ball. Sand is less than 5 centimeters, and it really can be defined by grittiness. And then silt and mud is the same size as sand, but it's going to be more slimy. So you may need to pick up the sediment to figure out if it's silt or mud or sand. Again, that texture is going to be the main indicator there. One other way to often see silt or mud is if it plumes when you disturb it and you see a lot of sediment go up into the water. Now, when you're calculating these percentages, it's really important that the total adds up to 100. That's something to double check for yourself as you're going through. And again, you'll be repeating this for every cross-section point. So let's work through an example. Now, this is one of the things that can be a little bit tricky, so it's helpful to do it by eye, and it's also helpful as well to look at this with a partner too. Jill and I were chatting about what we thought these percentages were in advance of this training, and we definitely had some different answers. So this is a nice spot, a nice time where you can like find a way to meet in the middle as well. So this view is approximately 30 centimeters across. You saw from Michelle about how big it was. But that can start with an initial size. So I can tell you that there are no boulders in this stream view. But yeah, would you like to like put in the chat maybe a category like of substrate classification that you see?
Or you can shout out too if you
Or
want
you
to
can shout
unmute
out.
yourself.
That's
Yeah.
true. Ooh, Cameron said cobble. There definitely are some cobbles, I
There's
think.
definitely cobbles.
I think gravel as well. Yep, there's also definitely some gravel. Is there anything else? It's a little hard to see. I know with like sand and silt and mud, that's going to be something that's easier to define when you're in the field. Now, does anyone have it? Oh yeah, sand in between. Nice, Daphne. Now this is a big question. Does anyone want to take a guess at what percentage of this is cobble?
It's more just to see if I was right or Isabel was right on
Yeah.
our
Or maybe y'all are somewhere in the middle. That's
or somewhere
perfect.
in the middle. Yeah.
Ooh, Daphne
Ooh.
said 75. Cameron said 80. Oh, I was very wrong.
I guessed about 70. Yeah. Yeah.
I was about at 55, which is looking at it now is definitely a little on the low side. So yeah, about 75% cobble. How much gravel would you say this is? Let's go with 70 so that for cobble so that
There you
percentages
go.
are nice.
Yeah.
So we were thinking maybe it's about I think oh yeah, nice. Daphne, you said 15. Yeah, I think we were thinking like 15 or 20% gravel, which means then that rest is sand. So if we said it's 70% cobble, 15 gravel, this is where math comes back. We're at 85%, so that
Yeah.
leaves us another 15 for sand. And maybe there's some silt too. We wouldn't know unless we can touch. But yeah, this is a great example. Nice job, folks.
Nice to know that we're about the same, area too. So it's really great to collaborate with each other when we're out in the field and see what everybody says.
Yes, exactly. All right. Sorry, I've lost my Zoom window.
Oh,
I'm so sorry. Give me
that's
just one
okay.
moment. Um, there we go. Thank you guys. All right, so periphyton. What is periphyton? It's a mixture of algae or other organisms that grows on the surface of rocks. So it doesn't have roots, which means you got to be careful not to confuse it with substrate-rooted aquatic plants, which might also be present. Really, I like to think of it as kind of the slimy gunk on the rocks. And in this section, we're going to be evaluating what percentage of the stream viewer view has periphyton in it. And again, only look at the area within the stream viewer, and you'll be doing this for all cross section points. So actually, let's use this example, this image as an example. So do you see that green on the rocks? That's going to be your periphyton. Does anyone want to write in the chat what they think that percentage would be?
Kind of hard to see. Yeah.
Yeah, it's a little hard to see, especially with that angle in the middle. Yeah. Cameron said 50. That's what I was thinking as well. You can see that some of those bigger cobbles have it. Yeah, Daphne said 45 to 50. It's both on those bigger cobbles and then also on some of the gravel too, it looks like. Nice.
Sorry.
Oh no, you're good. That was perfect. So yeah,
Okay,
that's
good.
another one
Okay.
where like with all of these visual ones, it's helpful to get a second pair of eyes from maybe the person next to you in your transect. All right, so yeah, here are some examples of the periphyton. So you can see that it's both the slimy filamentous covering growing on top of the substrate. So it can be green or brown, and the key thing there is that it doesn't have roots and it's not growing within the substrate. It's on top of the rocks. Now, once you've seen it and categorized how much of the view is covered by it, you also want to evaluate how thick the periphyton is. So, like, does it float over your finger if you brush up against it, kind of like is shown in these pictures? Or is it like a thick, slimy coat that you can't like put a finger underneath? So on your data sheet, it's going to ask if the periphyton is like greater than 2 centimeters, less than 2 centimeters, or like absent. And that's really referring to, is it long enough to like float over your finger? And again, you'll be repeating this for all of the cross-section points. Oh, I went ahead. There you go.
Oh, you're good.
Thickness.
But yeah, there's a good example of it floating too over the finger. Yeah.
Yes, exactly. Yeah, I was getting ahead of myself.
No,
Oh my
you're
gosh.
good.
Okay. So now this fourth characteristic that we're going to look at is embeddedness. So embeddedness is how buried the rocks are into the silt, sand, or mud at the bottom of the stream. So if you pull a rock out of the stream bed, you might be able to see a line indicating the part that was buried. So these photos have red lines to indicate the part that was buried. And so sometimes that line is really clear, like that one on the left. Sometimes it's a little less clear if the rock, especially if the rock is darker. And so you'll be evaluating the percentage of the rock that is embedded. And again, this is another kind of more qualitative measurement, so feel free to ask your cross-section neighbors. Sometimes it might be hard to see that line too. Again, like if it's that rock that's a little darker. So you might be able to feel a change in texture, like if one side is more slimy and exposed than the other one is. And you'll be doing this for all cross-section points. All right, now the last measurement you'll be doing in the transect is canopy cover. So this is a measurement of how well the riparian forest regrowth can reduce the light intensity in the stream bed. So that was like Michelle was talking about with keeping the stream cooler. So the way you'll measure this is by going to that middle cross-section point and looking straight up at the canopy cover. And the canopy cover is going to be the percentage of the view that's overhead that's covered by leaves and tree canopy. So this is a measurement, another qualitative one where you're assessing a percentage, and only measure this if the trees have leafed out, if there are leaves to see. If the trees haven't leafed out, like it's too early in the season, or if it's late fall and all of the leaves have fallen, record NA, and then if there's no canopy, record 0. So this picture right here is an example of like 75% canopy cover.
Great. Thanks, Isabel, for all of that. That's so much information, and I think you did an excellent job covering all that. So we're going to go into the next technique, and I promise there's a break coming, so hang in there with us. We're going to cover channel geometry. And when I say geometry, this is, yes, the stuff that you learned in middle school that you thought you would never have to do again, but we're going to make it nice and easy. So just an introduction to the channel geometry. What are we talking about? We're talking about the banks, basically. So we're going to assess the banks of the stream, and we're going to measure bank height, bank full width, bank angle, and then we're going to check kind of the stability of the banks, looking for cracks and slumps. So we're going to use those gauge sticks again, like we were using for the cross sections. We are going to use a protractor, and I don't know how long it's been since you used a protractor, but you will use one when we go monitoring. You will also use a little level just to make sure that we are taking things, at the appropriate height. Thank you. And we will also be using our measuring tape, and that's, pretty much what you had before you're going to have again. So here in this picture, just some examples when we talk about bank height, literally the height of the bank, and we'll go over how do you determine which bank to measure. There's also bank full width. So bank full width is different than wetted width, which Isabel talked about earlier. The angle of the bank. So here in this example, we have an undercut bank on the right side, and then we have a more broad bank on the left side. And then we'll look for those cracks and look at the structure of the banks. So bank height, again, what is bank height? It's the height of the bank. It's the point along the stream bank where a rising stream would expand beyond its channel into the floodplain. So sometimes it's obvious. Sometimes you walk up and you're standing at the edge of the stream and you know that at that point when the stream breaches that height, it's going to flood into the plain. I will say just from lots of in-person experience, sometimes that's hard to identify. And so sometimes, again, it's a crowdsourcing thing where we'll need to talk to one another and see if we can identify what we will determine as the bank height. And we do that on both sides of the stream, both left and right. So again, here are just some examples. So if the bank is sloping, we try to create as much of a 90-degree angle with our gauge sticks, so that way we can get the appropriate height. And then of course you measure the underside just so you're measuring the actual height of the bank, not including the stick. If it's a really nice up and down bank, it's pretty easy. You just measure the top of the bank. And then if it's undercut, like the example on the right-hand side, again, we got to make sure that gauge stick is standing up nice and tall and straight. We can also use the level that we'll provide here just to make sure that it is absolutely standing up straight and to not tilt it into the gap. Oh, Isabel, I'm going to move your head. I'm sorry. So one way that the measuring tape can come in handy is if the bank is too tall. I mean, I saw a bank today that was much taller than I am, and so we can use the measuring tape or maybe stand gauge sticks on top of one another, but we will measure bank height. All right, and like I said before, some banks are more complex than others. So we will measure the lower of the banks on the two sides. So in this example, you can see that the banks are not equal height, but where we take the measurement of the height, we're going to take it where you can see it starts to crest and then fall away. So even though they're not the same height, there is still a bank height where the water will spill over into the floodplain. So sometimes it's a little hard to find and determine, especially when you're standing out along this creek and you're looking and you're like, where is it actually flooding over? And we can work with each other to determine that. So here's a good example of where you can use your field tape too. If your bank height or your bank is a little bit further away from actually the edge of the wetted width, which Isabel mentioned before, we might need to use our measuring tape to capture that distance and get that height. So bank full width. Bank full width, again, is different than wetted width. It's the elevation point along the stream bank where a rising stream will expand beyond the channel into its floodplain. And we will always take the, like you see here how there's two, again, like one is lower and then one is higher up. So typically we measure that from the lower all the way across. And then there's also field indicators. If there's changing in bank slopes, there's depositional features, if there's vegetation or not. And we're going to look at some of those examples here. So when we have even banks, no problem. I can easily identify bank full width. It's from one edge on the left side to the other edge on the right side. We measure that with our measuring tape. So it's an idealized situation, which we probably won't run into very often. More likely we'll run into uneven banks where one bank is higher than the other. And so again, we look to the lower bank, which is here on the left. And you see the bank on the right side is much higher. So we just go as straight across as possible using our level and our measuring tape. Now, sometimes we do have ravines. I'm going to say sometimes. This is not very common, especially for probably the monitoring that we're going to be doing. But this is when you need to look for that evidence along a ravine wall. So like, are we looking for debris, scouring, absence of vegetation, where you can tell where sometimes there's this maximum point that the water hits. And we will consider that the bank full. So that can be, again, something that we might crowdsource in the field and all come to an agreement on. And this is also why we take photos, which I will go into later. And then on the right side, we have what is known as a step or a higher bank. So on the left side of that figure, you can see there's actually two steps. we try to do, again, the step where it will flood over into the floodplain. So we will not take bank full at the lower step, we'll take it at the higher one where the water would crest and go over into the floodplain. Sometimes that's hard to identify, but again, we'll work together to figure that out. And some banks seem to go on forever. This is very true. So we just do our best to estimate where the top of that bank is located. Again, we take the measurement from the lower bank across as level as possible to the higher bank. And these can change from time to time too. So you might go to a site in the spring, and when you go back in the fall, it might be a little bit different. Maybe some of the bank has slumped or changed. So that's why we measure this every single time we go out there. All right, now we also measure bank angle. Why do we measure bank angle? Restoration can result in the streams shifting, and that can result in scouring of the bank where it can be undercut. So you have that hanging over of the top of the bank, and then it's like angled inwards almost. So it's less than a 90-degree angle, or if we all remember the term acute, it's an acute angle, so less than 90 degrees. It can also be more sloped the other way. So it's going to be greater than a 90-degree angle. And those types of banks are considered more stable. So sometimes we go out and maybe it's a perfectly up and down bank. So it's almost 90 degrees. And then over time, it might actually slope out due to the restoration efforts. So angle is important to measure when we're doing this. And we do this at each transect. Okay, so we are going to use an actual protractor with the arm that is adjusted. I will say this is easier to understand in practice, but we will try to go through it here. So let's just take this top example and on the left. So you lay your gauge stick along the slope of your bank, and then you lay your other gauge stick flat. So that's where we use our level. And then we measure the angle, and you can see it's the top, like, kind of stream side of the angle. So that is going to be the angles of that bank. So here in this example, because it's sloping away from the stream, it is greater than 90 degrees and is, in this example, 125 degrees. Now on the opposite side, on the right-hand side, that's that undercut that we were talking about before, where the top of the bank kind of hangs over. You try to get your gauge stick in there as best as possible. Again, you have another gauge stick laying on the top of the bank that's level, and then you measure the upper stream side portion, which here in this example, since it's an acute angle, it's less than 90 degrees. In this example, it's 60 degrees. Again, this is easier to see in practice, but then there's another example here at the bottom where now, the left side is pretty much the same, but on the right side, we have that step bank. So remember, we take the highest one because that's where it floods over into the floodplain. And then also now it's sloping away. And so now instead of having an acute angle, it's now greater than 90 degrees. I will say this is probably the part when I'm out in the field, I have to stop and I have to think about it and I have to read the manual and say, okay, wait, where is it sloping? Which way is it going? So this is a part that can take a little bit of practice. So no pressure if this is a little bit unfamiliar. But we are going to try dusting off those geometry skills with you right now. So on the left-hand side, we have two protractors here. So we'll look at the one first on the left. So we have an undercut bank. So the top of the bank is kind of overarching. And then we took a measurement. And so out of this figure, we want to know which number do you use? Do you use the 130 that's on the top, so 130 degrees? Or is it the 50 degrees that's the bottom number? And then same on the other side, on the right side. So now we have a sloping away bank, and we have, the numbers are kind of reversed actually. So now 50 is on top, so a smaller number, less than 90, or we have the 130 degrees. So pick left or right, and maybe in the chat, give us which you think it is, which number you think it is. I know math is intimidating, but please give it a try. We're all here to learn. And then we'll share in just a second, but if anybody's brave enough. I I see a chat. Hang on, let me scroll.
Cameron said left.
Okay. And left, do you think it's going to be the 130 or the 50, Cameron? Nice.
Ooh, Andrea said left is 50.
Yes, excellent.
Oh, same with Daphne.
Oh, you guys are great.
Y'all are
This is
pros.
so easy for you. Much better at math than I am, I will say that. So then on the right side is going to be the opposite, right? So on the right side, because it's going away, we're going to use that larger number because it's greater than 90. You guys are perfect. A plus, everyone is awesome. So if you ask for my help in the field, I'm going to say, I know you know this. So, okay, perfect. And then we look for cracks and slumps. You probably you've gone out into a creek, you've probably seen this. Cracks and slumps are a type of bank erosion. And it's just kind of, a sign of instability on the creek bank. We do want to be careful if we are walking along, especially if it's cracked. If it's already slumped, it's already slumped. But if it's cracked, we do want to be careful with our footing because you can step on it and it may actually slump out from underneath your feet. So that's just something to be aware of. But we will look at the sides of the creek banks and just see what is maybe potentially going to slump or maybe has slumped since the last time we were there. And that just kind of gives us an indicator of how stable the stream banks are. Okay, we're gonna take a break. You guys have been amazing. You can ask some questions now if you want. We do encourage you to stand up, go get a drink of water. We've been going for about 45 minutes. Y'all are troopers. We have a few more technique sections to go through, and then we'll get to the end where we show you the sites and give you the information to sign up for a site. But how about we come back? Let's see, my phone says 6:51, so let's come back at 6:56. But feel free to unmute or even in the chat, ask some questions if you have any. everybody. We're back. All right, let's just get situated here. Move Isabel. Okay, so for the next section, we are going to be talking about the biological habitat and how we monitor that. And Michelle is going to take this section for us. So take it away.
Sweet. So, biological habitats or stream habitats at large are really important because healthy stream water essentially provides various habitats for diverse animal and plant community to thrive and grow. And in order to have diverse animals, we need diverse habitats. And so, this visual assessment part of um, our workshop today will help us contextualize some of the numbers we calculated earlier. So looking specifically at stream angles, bank angles, as well as temperature, clarity, what does it all mean as a whole? So in this next section, we're going to um, think back a little bit from what we learned before about transects. So picture yourself in a stream right now in a transect, and essentially we'll draw a line 2 meters to your left and 2 meters to your right for a total of 4 meter wide corridor where we will assess whether or not the following habitats are present. And so in this section, the habitats include logs and large woody debris as well as small woody debris. So logs, the large portion would be things that are bigger than an arm, and small woody debris would be fallen twigs and branches, typically on the side, but they can fall in the middle as well. The next habitat are leaf packs. So usually brighter in color at the end of the fall season, you see a bunch of leaves fall in the streams trapped between the rocks. And then we also have cobble as well as boulder. So again, these should sound relatively familiar. These are our larger size sediment rock type things. So boulders are things bigger than basketballs, and cobbles are things from tennis balls to basketball size. And this is a good opportunity to again record any of the cobbles or boulders that you see nearby but weren't like directly within your stream viewer. So now you can record it and check those boxes. And then the final one on our slide here is riffles, which essentially is that break in the water, and it's when the water kind of speeds past a little, and it's usually because there's a big rock or a bunch of branches there or something. So kind of that shininess in the water, and then it just runs like a rapid, mini rapid, yeah. Okay, and then we have a couple more habitats. So starting with tree root watch, this one always confuses me about saying it. So this is dead trees, branches, twigs, a lot of organic material, and it's good habitat for fish and macros. And we also have overhanging vegetation. So this one should also sound pretty familiar. Trees and shrubs that provide shade and cover for uh, wildlife in the water. And up next is aquatic vegetation. So unfortunately, this category does not include any algae or periphyton that we've covered previously. We're looking for vegetation that are rooted on the rocks and the sediment. So sometimes it's helpful if you bend down and tug it a little bit. Usually green or brown in color. So things like watercress, if you've ever eaten it, starwort, and those things. And then last but not least, we have undercut banks with roots. So as you might remember from the protractor example, this is when the water kind of erodes the bottom part of the bank before it gets the top part, and you're left with a lot of organic material within the banks, the underneath of the bank. So again, it provides great habitat for fish and macroinvertebrates. And so in our data sheet, there will be boxes where you check these off. So if you see one really big boulder, then you can go ahead and check your boulders as for the rest of them. So up next is our riparian areas or riparian zones. And essentially this is all our tree cover and basically everything green. And it's really important to have riparian zones because it helps us remove and filter through excess sediment, nutrients, as well as provide stability for the banks and reduce the impacts of crazy flooding. So we'll be bringing in the concept of riparian buffer transects. So you should be familiar with transects by now in the stream specifically, but now we're gonna imagine and draw, kind of picture out a line. So this part again isn't quite intuitive sitting in front of a computer. It's probably more intuitive once you're out in the field seeing it. So essentially, for our transects, we want the bankful widths of the stream, two bankful widths. So we're going 2 times the size of the stream on each side. So for a combination of basically 5 streams, if that's easier to picture. And on each side, it would be roughly between 10 to 30 meters wide, where we'll be assessing the trees and greens basically. So the equipment we'll need is the tape measure as well as gauge stick. Oh, and I forgot to mention that within our 5 streams wide in total, so that big red line there, we'll also be assessing the same size corridor, so also 2 meters to the right and 2 meters to the left for a total of 4 meters. So we'll be repeating this each during the upstream, midpoint, and downstream of the stream for a total of 3 riparian buffer transects. And so once you have the riparian buffer transects set up and established, this is the fun part where you're able to walk through the transect you set up for yourself and tally up and record any trees you see. And so we'll be breaking it up to 2 main categories: pre-existing trees. So the trees you think of when you normally see pretty well developed out there, like you can kick it and it won't fall over. And then we also have newly planted trees. So these are typically in green plastic tubes. If you look really closely to the picture in the back, you might be able to see a couple. And so the tubes make them helpful to identify, but once they mature a little bit more and the tubes go away, we're looking at trees with the diameter at breast height or gauge stick height of roughly 5 centimeters or less. And then this part is really important to track because it allows us to see whether restoration and buffers are doing well and possibly what impacts they have. So yeah, and then we'll also be sketching out the riparian area and if you're a tree expert and are up for a challenge, you can also note any concerns like any invasive species or identifying the trees planted. Again, would support kind of what's next from the restoration perspective.
Great, awesome. Thanks, Michelle. Yeah, the riparian zone is always interesting. It can vary quite a bit to either like kind of what we saw in the picture where it's really easy to walk along, and sometimes it's a little bit more challenging. So it can always be fun. All right, so I'm going to jump now into these stream reach photos. So they are standardized. So that way we can actually monitor changes visually over time. So they help us to contextualize this additional information and data gathered. Sometimes maybe we make some observations about the stream banks and things, and we see slumping or the cracks, and maybe they change over time. These photos just help support the information that we're documenting. And photos are just nice too. There's just a nice visual way to understand the stream restoration. Before and after, always very interesting. So for the stream reach photos, we will be taking 12 standardized photos. 6 of them we're going to have a whiteboard, which actually describes the site and what the photo is going to be of. So where you are in the stream, if you're looking up or down, and then 6 photos without that whiteboard. The whiteboard is to make sure that when we're going back through our phone roll, we actually know what photos we're looking at. Because I don't know about you, but I can take a ton of photos and then later look back and have no idea what I'm looking at. So it just helps us keep track. So the equipment used for this section is going to be the whiteboard and a marker, the gauge stick with a phone holder, which we will show you here, your own phone, and then a tape measure and flags. So the photo nomenclature, it's not super important to understand or remember this right now. We have tables and it's very well documented in the manual. But what's important to document when we do our whiteboard is where we are, which transect. Are we, are we on the first one or no, not the transect, I'm sorry, the cross-sectional points that Isabel was talking about before. So Oh no, I was wrong. I'm so sorry, Isabel. So this is actually, we're taking these photos in between those transects, my bad. So we're going to be 25% of the stream reach. So transect 1 is like our 0 point, and then 25% is between, 50% is our second transect, and then 75% is between our second and third transect. We need to know, are you looking upstream or are you looking downstream? That's really important. And then we're going to number the photos. And so we take the photos in the same order every time. So the first photo is number 1, etc. So in this example, this photo was taken at the 25% point of the reach. We are looking downstream and it was the first photo that was taken. They also documented what side of the stream is the left bank and what side of the stream is the right bank. And another great thing in this example is they wrote the date, which, sometimes there's not a lot of change in the photos. So it is good to document the dates when you're going back through. You actually know which monitoring period you're looking at. Okay, so we're going to establish these photo locations. Again, this should have been done prior. I don't know if you remember way back when I started, we talked about setting up the site and documenting these points along the reach of the stream. And so you can see here in the figure on the lower right, we have our 25% reach between our first transect and our middle transect. The 50% reach is that green starred, so that's right along the transect in the middle. And then our 75% reach is going to be between the second transect and the third. And just to note too that the 25% and the 75% are taken along the shore. They're not taken from the stream itself, but the 50% is. So that's really important to remember when you go out and do these photos. So if you want to show what you got it set up and everything. Yeah. So we have a stick here and Michelle's put her phone in. And so basically what you'll do is just stand it up and you'll point downstream, whiteboard, take a photo, and then turn, whiteboard, and then take photo. And then you'll do that at each of these points. And this gauge stick is, honestly, you can use this gauge stick as your secondary gauge stick when you're doing like the big full heights and stuff. So you're not carrying a bunch of gauge sticks everywhere. So if you want to minimize how much stuff you're carrying, you can use this as one of them. Okay, so the first one we do, like I said, we start at the 25% reach point. So we're going to be starting with our photo 1. We'll be looking downstream. So we start here. So this is what those dual photos are talking about earlier. So we do one with the whiteboard so we know what photo we're looking at, and then the actual photo that is taken. Again, it just helps us keep track of what we're looking at. And then we turn the other way. Now we're looking upstream. And then we go to the 50% reach. Now, again, this is in the middle of the stream, not on the edge. And so you can see the examples on right. We look downstream and then we look upstream. And then the numbers on the end keep going up as we take our photos. So eventually we'll have 6. So once we get to this point, we're already more than halfway done. And then we get to the 75% reach point. So then we are downstream is 5, upstream is 6. And so eventually, this is what your mapping out will look like. You'll have 6 photos, 3 looking downstream, 3 looking up. But total, you'll have 12, remember, because we're going to have the whiteboard in between. And this is the coverage that we're going to have of all our sites. And this is really important, again, to be standardized, to cover as much of the reach as possible. And when you all start doing this on your own without our assistance, it's good to look back at the photos that were taken the time prior, just to kind of make sure that you're familiar with how much is covered in the photos. We try to get, as much covered as before so we can really see those changes. Here's just a table. So this is in the manual that you will receive of just all the photos and the nomenclature that we use to describe them, which ones have whiteboards, which one don't, where you're looking. So again, 12 photos in total from 6, 3 positions and then up and down. It's a lot, but very, very useful and very helpful. Okay, and so I think Isabel is going to close us out here with the almost last set of techniques where we're going to do the general reach characteristics.
Yeah, thank you, Jill. So kind of continuing to take that step back that Jill mentioned, we're looking at general reach characteristics. So this is taking into account the entire stream reach and not just the transects, not just the photo points. It's the entire section that we're monitoring. So you'll start with doing a reach category. Oh, I can't pronounce. You're categorizing the reach and splitting it up into pools, riffles, and runs. So this is another percentage one, and this total percentage should add up to 100%. So you might be familiar with some of these categories. I know Michelle described riffles previously. So those are those areas of fast-moving, shallow water that flows over substrate and breaks the water surface. Pools, that's slow-moving deep water and often found on the outside of bends. And then runs are those areas of the stream where the water is unbroken, the flow is smooth, and oftentimes it's the area between the riffles and the pools. So with those, I'm going to call out those riffles in particular again as well. So while you're doing the categorization and deciding how much, defining the percentages and seeing how much of the stream is each of those 3 categories, make a note of where the riffles are, because you also will count the number of separate riffles and add that to the data sheet too. And you'll be coming back to these later. So the next thing you'll do is aquatic vegetation classification. So begin by assessing the water color. It might be helpful here to use your transparency tube to fill that up with water, because looking at the water in the stream isn't a really good way to see what color it is. It's really helpful to take that water out so you can isolate just the water and not have the sediment or other parts of the stream affecting what you're able to see. So looking at that color, is it green? How green is it? Is it just a little hint of green, or is it pea green? And this can hint towards algal growth. So continue to look at aquatic vegetation by estimating the percentage of aquatic vegetation. So how much of that entire stream channel is green? And so this is where we care about that vegetation that has roots that Michelle mentioned. And this includes both aquatic plants, macrophytes, and filamentous algae. Now you want to look at the banks too and look at their condition. So looking at the left bank and the right bank separately, you want to estimate the percent bank coverage for each of the categories listed here. So how much of the right bank is covered by grasses, trees, shrubs, concrete, riprap lumber, so like that human-made banks, bedrock, soil, or how much of the banks are impacted. And you want to do this for each of the two banks. And again, these are percentages that should add up to 100. So this is helpful where you walk along the bank, see what you can find. You'll be doing this walk along the stream, looking both for the reach classifications, keeping an eye out for aquatic vegetation, and also estimating the condition of the banks as well. So now I've got some examples. So we have this left example here. We'll say that's example A or example 1, whatever you'd like to call it, and the right. So keeping in mind those categories I just mentioned, what would you designate these bank conditions as? Each one of these, I would say, fits into really one main category, or they each have their own main category. Would anyone like to put in the chat if you recognize anything?
I'm gonna go back one slide so they can see the names again.
Perfect. Thank you, Jill.
Yeah. And then here.
I think you may have seen one of these pictures earlier on in this presentation too,
Yeah.
and that might give you a hint. If you don't have any ideas, that's okay. I'm happy to share. Oh, nice. Oh, Daphne. You're right. That left one there is human-made and riprap in particular. Nice job. Oh, I see you messaged that to me directly. Yeah, fantastic. And the right is slumpy. You are right. Nice job. So I think the way it was categorized in the data sheet, as you'll see, it'll be bank impact. So that includes a couple different impacted banks, but you are spot on that it is a bank slump. Nice job. All right, so next you'll be looking at signs for floodplain inundation. So this is when the stream rose over that bank full width and spilled out into the floodplain. So some signs of this might be water rings or stains around trees, also lines of leaves, twigs, or trash that was carried and deposited, or flattened vegetation. So you're looking for those signs of flooding in this section here. You also want to look out for impacts of animals. So one of these pictures might also look a little familiar to you. I think you maybe just saw it a couple slides ago. So you can see these are two examples of what it looks like when animals are accessing the stream. So in the section 2, observe and record. Also, if the animals are fenced out of the stream, so do you see fences keeping the animals out? And are those fences working? Are they still up? Are you seeing those impacts of animals in the stream? All right, and that concludes your full reach monitoring. So this is the final step, which you'll only do in the spring, like Jill mentioned, and it's benthic macroinvertebrate sample collection. So if this is the fall, you're done. You've finished your sample collection, or you finished your monitoring. If it's the spring, we've got one more thing, but that's all right. So this benthic macroinvertebrate collection protocol focuses on 6 double wide kicks with a D-net. So you can see that in the illustration on the left there. And so those double wide kicks include both rubbing rocks with your hands to dislodge any macroinvertebrates that might be on them, and then also disturbing the sediment. And both of those things will take a total of 60 seconds. And so each time you do that, that's about 60 seconds per kick. So you'll do that twice, one next to the other to make a double wide kick. And then you'll repeat those double wide kicks 5 other times. So you've got those 6 double wide kicks to collect the macroinvertebrates. And so this is where those riffles I mentioned come back. You want to be collecting macroinvertebrates in riffles. That's the best spot for them to live. And while you're doing this, do your best to avoid sampling on riffles that are located in the transect. But of course, this is the thing you'll be doing last. So if you do end up disturbing some sediment and disturbing the transect, that's all right. That's why we do macros last. Um, Now, once you've collected all of the benthic macroinvertebrates from all of your kicks, you'll transfer them to a jar with ethanol to preserve them, and then we'll be sending them to a lab to be identified to family level. And so this is the biological assessment that complements all of the physical and visual characteristics that we've been measuring throughout this entire sampling process. And so once you finish this, you've finished your monitoring day.
Awesome. Thanks, Isabel. And thank you, Michelle, too. Appreciate all your help today. So now we've gone through the monitoring protocol. We've talked a little bit about the benthic macroinvertebrates. Now it's time to pick a site. So we do have 3 locations. I have already received a lot of people wanting to sign up for Campbelltown. I will say that we are pretty much at capacity. If you're still interested in that site, please let me know. Please don't let this dissuade you. It's just that I want to make sure everybody has an opportunity to try all the techniques and participate fully in the monitoring. And if we have a large group of people, you might not get the experience that you're hoping for. We are still looking for volunteers in Quarryville, which is B on the map, which is just south of Lancaster. So we only have 1 volunteer signed up so far. We are definitely looking for more. And that is going to be on March 29th. That's going to be in the morning from 9 to 1. And that will be with Maya, who's with the Alliance for the Chesapeake Bay. And then also, if you're feeling adventurous, go to Maryland. There's a site in Westminster, which is C on the map there. So it's northwest of Baltimore, just over the border. And that is also going to be a morning on a Saturday, April 5th. And that is also Maya's site. So when you're ready to sign up, you can email me or Maya, whichever, but please let us know which site you are interested in. Again, I'm going to encourage people to go to Quarryville just because we do need some extra hands down there. But just let us know which ones you are interested in participating. And just so you know, like we are hoping for good weather. These might get delayed or rescheduled if the weather just doesn't look good. We don't want y'all out there suffering. I don't want to be out there either if it's raining. So hopefully we can go on the days that we have listed here. So who do you contact? That's me. So again, I'm with ALLARM, the Alliance for Aquatic Resource Monitoring. There's my name and my email, also my office phone number. Any of those ways are great to contact me. I will also email everyone who registered for the protocol training tonight, just to make sure you have the link for this training that we just recorded. And then also you can contact me, you can respond to that email and let me know which sites you would like to sign up for. If you are interested in doing either Quarryville or Westminster, you can contact Maya directly. Again, Maya is with the Alliance for the Chesapeake Bay. She's a lot of fun. I'm sure probably some of y'all have already met her or at least seen her other orientation. So you can email her or call. Again, you can reach out to either one of us for any of the sites. So I am going to stop sharing and all right. So if anybody has any questions, now is a great time. We have tons of time. It's not even 7:30 yet. So if there's anything you want to address now, please feel free to unmute or chat. You're free to go if you like and you want to go get some dinner and enjoy your evening. We really appreciate all of you coming and participating tonight. We really look forward to seeing you out in the field. And if you have any questions tomorrow or any other day, please reach out to me. Again, we can answer any question about the protocol that you might have or something that wakes you up in the middle of the night and you're like, wait, how do we do that bank angle again? Just let us know and we can help you out with that.
Yeah, I have a quick question here.
Yeah, Cameron, go for it.
In the beginning of the training, you were mentioning this initial orientation session.
Mhm.
Where could that be found? This little program here was introduced to me through the Master Watershed Stewardship group. So I don't know if you sent that to Jim or if I'd have
Ah,
to get that from you.
Yeah, it's probably something that Maya's been working with Jim a lot, to spread the word about this. So I will make a note when I have a pen. Oh, thank you. Um, I think Maya has them recorded, and it is a brief overview. I mean, this was the in-depth portion, right? But Maya does have like a brief overview of, just kind of the background, how this project got started, what are some of the things that are involved, why does it matter? So I will email Cameron link to orientation. It's only, I think she busted out in less than 30 minutes. So you can just watch it online, but I know she has it available. I just need to find the link and I will send that to you.
Okay, sounds good. Thank you.
Awesome. Thanks, Cameron. I know you're all excited. We really hope you come out and join us. I'll give you like a couple more minutes to think about things you want to ask.
And yeah, it's one thing to see it in a presentation like this and another to be out in the field doing it. It's a little bit easier to visualize and explain and be a part of as you're hands-on with the techniques. So
Absolutely.
it might make it might be a little smoother as well.
Yeah. And when you do one transect, the other two just go like that. So we do say, be prepared for 3 to 4 hours out in the field. I'd say 4 plus, depending on how the benthic goes in the springtime. So, for us, it's about an hour commute to the site. We're there for about 4 hours. It's an hour back. So just be aware of the time commitment. If you start with us and we have enough people and you have to go, that's fine. We won't hold it against you, but we really hope that you come out and you stay the whole time with us for the monitoring. You might see Michelle. I don't know if we can drag her out there to do it with us too. You might see some ALLARM personnel or ALLARM students too, might also join us out in the field. Okay, well, I'm gonna go ahead and call it. Thank you again so much. You will be hearing from me soon. I will send you an email with all the fun things. Might not be tomorrow, might be Thursday. But we really appreciate you taking time out of your evening to join us tonight, and we look forward to seeing you in the field. So I'm gonna go ahead and end the recording.